Alright guys, so in this video what we're going to be talking about is how we can combine random variables with one another. So this is going to be slightly different from transforming random variables. With transforming random variables, we were really just always dealing with one variable and either adding or subtracting or multiplying or dividing that one variable by a number. Now we're actually wanting to put two variables together. So let's talk about the rules for that. Let's start with the mean, and mean is quite a bit easier than standard deviation. So for the mean, if we want to take the mean of two variables being added, x plus y, we can just take the mean of our first variable, x, plus the mean of our second variable, y. So anytime you want to add the means together, you can just do that directly. Just add the two means up, and then there's the mean of your new variable. Now, standard deviation, we need to talk about variance first, and we'll remind you kind of how the two are related once we've done that. But the rule is actually the same for variance. So for variance, we can actually take the variance of x plus the variance of y. So that kind of follows nicely, kind of just like the mean. Now notice, for variance, we do have an extra thing that we need to check. The variables have to be independent in order for us to be able to add the two variables together. Now really, we're not so much interested in variance as we are standard deviation. And it's been a while since we've talked about variance. Remember, variance is standard deviation squared. In other words, the variance of x plus y would be the standard deviation of x plus y, all of that being squared. And so then the variance of x would be the standard deviation of x squared, and the variance of y would be the standard deviation of y squared. Now really what we're mostly interested in is just the standard deviation of x plus y. So we're mostly just interested about what's inside of the brackets. And so we need to get rid of this exponent of 2. And in order to do that, remember, we just need to take square root of both sides of our equation. So that would give us standard deviation of x plus y is equal to the square root of our standard deviation of x squared plus our standard deviation of y squared. And so it actually turns out that this is going to be what we'll have to do in order to find our new standard deviation, which isn't too bad. Really what it kind of should feel similar to is Pythagorean theorem. Kind of how you would solve Pythagorean theorem is a squared plus b squared equals c squared. Same idea here is that you take your first variable squared plus your second variable squared, and that gives you your third variable squared. Okay, so let's take a look at how this is going to work with an example. So in this example, we're going to let B represent the amount of money that's spent on books in the fall semester for a randomly selected student at El Dorado Community College, which we were talking about in our last video. Suppose that the mean for the amount spent on books, so mu sub B is 153, and standard deviation is 32. Recall from last time that we actually found the cost, so the variable for cost for a randomly selected full-time student was that mean of C was 832 and 50 cents, as well as the standard deviation, which is 103. So let's go ahead and find the mean and standard deviation of the cost of tuition, fees, and books, so C plus B, for a randomly selected full-time student at El Dorado Community College. Okay, so that's really what we want to find as our new variable, which they say C plus B. I'm going to write that as B plus C, just to make it go kind of in the same order. Now remember that the mean of B plus C is really just taking the mean of B plus the mean of C. And the mean of B we had right here was 153, whereas the mean of C we had right here was $832.50. So really all we have to do to find the mean of B plus C is to add those two means together. So if you take 153 plus 832 and 50 cents, we get $985.50 as our mean for our combined variable. Now remember, for standard deviation, we have to do that squared. So let's in fact just write it that way first. So our standard deviation of B plus C squared is equal to our standard deviation of B squared plus our standard deviation of C squared. All right, so we're going to take our standard deviation of B, which was the 32, and square it, plus our standard deviation of C, which was 103, and square it. And so once we've done that, we'll go ahead and get our answer. So I'm just going to type that all into the calculator. 32 squared plus 103 squared is 11,633. Now remember that this is the standard deviation of B plus C squared. In other words, it's our variance. So we still have one last step to go if we want to get the standard deviation of B plus C by itself, which is that we now need to take the square root of that number. So again, kind of think about this as being similar to a Pythagorean theorem problem, taking the square root at the end. And then that's going to give us our standard deviation of 107.86 to 2 decimal places. Now, we did that. We should have checked something first, which is that the variables were independent of each other. In other words, does the amount spent on books depend on the number of classes that you're taking? And it might a little bit, but I would say that those are independent of each other enough that we are okay finding standard deviation. So let's take a look at another example of this. So suppose that the height m of male speed daters follows a normal distribution and has a mean of 68.5 inches with standard deviation of 4 inches, whereas the height of female speed daters follows normal distribution with a mean of 64 inches and a standard deviation of 3 inches. What is the probability that a randomly selected male speed dater is taller than the randomly selected female that he is paired with? So let's go ahead and find our combined distribution. So when we want to do that, let's look at the difference of our heights in this case. Because what we really want to know is what is the probability that the male is taller than the female. Another way to think about that, if you wanted to rewrite it, would be the probability that the male's height minus the female's height was greater than 0. So really, this is our variable that we want to find, is male minus female. So let's go ahead and find the mean first. So the mean of male minus female. Now this is going to be the same as the mean of males plus the negative mean of females. So when we want to do subtraction, we actually have to keep it as addition by the negative, which seems kind of silly, especially for means because it's doing the same thing. But for standard deviations, that's actually going to be really important. All right, so for mean of our males, that was 68.5 inches plus the negative mean for our females, which was 64 inches, so negative 64. And if we take 68.5 plus negative 64, that's going to end up being 4.5. So that would be the mean of males minus females would be 4.5 inches. Okay, next let's go ahead and find the mean of, or the standard deviation of males minus females. And remember, we're going to start by finding that squared. So again, that's going to be the standard deviation of males squared plus the negative standard deviation of females squared. So that's going to end up being standard deviation of 4 for men, so 4 squared, plus a standard deviation of 3, so negative 3 squared for females. And so again, that's where this is really important that we use plus and negative. Otherwise, you would end up trying to take a minus and take 16 minus 9. And actually, we need to do 16 plus 9 when we square both of those. So important when you want to do subtraction that you are being very careful. But 16 plus 9 does end up being 25. Remember, that is still just the variance of males minus females squared. So we still need to take square root of both sides. Square root of 25 ends up being a nice number, which is just 5. So there is our standard deviation for males minus females. Okay, so now we want to know what is the probability of our new variable being greater than 0. So again, this is what we are looking to find. In order to do that, let's kind of figure out how we're going to find this probability. And this is where it's super important that we were told that both of our variables followed a normal distribution. So we should be able to use normal CDF in order to calculate this probability. Now, we want to know what the probability is that it's greater than 0. So that means if you think about what that'll look like on a normal distribution, I'll draw that down here. Greater than 0, wherever 0 falls on this normal distribution, I guess our mean was 4.5. So 0 would be somewhere over here. And we want to know what is the probability that it's more than 0, meaning that 0 is going to be our lower bound. We're going to pick a number much, much higher than 0. So something like 20 or 30 or 40, probably 100 is what I will use. And then we'll put in our mean, which is 4.5, and standard deviation, which is 5. And then that should give us our probability that we need. Based on the graph that I just got done erasing, that looks like it's going to be a fairly large number as far as probabilities go. So probably a pretty large chance of the male being taller than the female. All right, so let's go ahead and put that in normal CDF, 0, and then I'm going to use 100 for my upper bound, 4.5 for our mean, and 5 for standard deviation. And that's going to give a probability of 0.8159 to 4 decimals. So a little bit less than an 82% chance that a randomly selected male speed dater is going to be taller than female. And that's kind of something we should expect anyways. Okay. So in this last example, suppose that we have a certain variety of apples that have weights which are approximately normal and have a distribution of 9 ounces with standard deviation of 1.5 ounces. If a bag of apples are filled by randomly selected 12 apples, what is the probability that the sum of the 12 apples is less than 100 ounces? So once again, we're going to be using some of this information to first find a new mean and standard deviation, and then we'll use that to find a probability. Okay, so let's talk about mean first. And I'm just going to call the number of bags, or the weight of the bags, or weight of the apples, X. So if I want to find the mean of our total number, or of our bags, that would be the mean of each of our apples being added together. And we're going to do that because there are 12 apples in the bag. We're going to end up adding those together 12 times. Now the mean of our apples was 9 ounces, so that would be taking 9 plus 9 plus 9, and then doing that 12 times. Remember that when you are repeatedly adding like that, you can just change to multiplication. So we can take 12 multiplied by 9, which is 108. So the mean for our bag of apples should be about 108 ounces. Next, we'll go ahead and find the standard deviation for our bag of apples. Remember, to do so, we're going to have to do those squared. In other words, we'll take the mean or the standard deviation for each of our apples squared and add those together. Once again, since we're doing that for 12 apples in a bag, we're going to end up doing that 12 times. So that would be our standard deviation, which was 1.5. So we're going to take 1.5 and square it, plus 1.5 and square it, and continue to do that 12 times. So once again, we can actually go ahead and use multiplication. So that would be 12 multiplied by 1.5 squared. And so what that's going to give us, if we take 12 multiplied by 1.5 squared, we get 27. Remember that that is for the standard deviation of your bag squared. So to find the standard deviation of our bag, we still need to take the square root of that number, which is about 5.196. So if we go to 3 decimals. Oops. Get back to where we were, 5.196. Okay, so now that we've got our mean and standard deviation, let's think about what we're trying to find. Again, we were told that it was approximately normal, so I'm going to draw that using a normal distribution. Our mean that we were looking at was 108, and then I won't label the standard deviations, we'll just kind of use this. So we want to know what is the probability that the sum of the apples is less than 100 ounces. So 100 would be somewhere over here, and we want less than that, so we want this area right here. Okay, so what we're looking for is what is the probability that our bag of apples weighs less than 100 ounces. And again, since it's our normal distribution, we'll be able to use normal CDF in order to find that. For our lower, we're going to pick something very, very small. So I'm going to write negative infinity to just say something, pick something a lot less than 100. So probably 0 is what I'll end up picking. Then we'll go up to our upper, which was 100. And then don't forget to type in both your mean and your standard deviation. All right, so when we do that, normal CDF, I'm going to go from 0 to 100, mean of 108, and standard deviation of 5.196. I'm getting 0.0618 to 4 decimals, which again looks about right. If you look at that area, definitely looks like a pretty small percentage compared to the last one, so about 6% seems reasonable. All right, guys, that is it for this section of the notes. In our next section, we're going to start to talk about the binomial distribution. Until then, have a great rest of your day.